All right. So what I'm demonstrating today is the Deephaven CSV parser, and in a way, it's just kind of like a workaday tool like any other CSV parser. But um, in another way, it's kind of cool because we feel like we put a lot of effort into making it fast and kind of making it uh, interactive, and also kind of making it have a kind of do what I mean quality to it. And so that's in part that's aspirational, and in part that's reality. And what I mean to say is, you know, we want to make it sort of fun to like load up Deephaven, go like browse some CSV files, kind of mess with them, maybe iteratively retry things with various options, get things to work the way you kind of want them to work, and then incorporate them into the rest of your application. So what I'm going to show is a few different examples of that, and I'm going to start with something very simple, like ooh, I wish I could show this. Um, um, Shoot, I don't have a way of showing this. Um, let's imagine. Let me, I don't want to switch screens here. What I'm starting with is a couple of very small files at first, just to get you a feeling for the do what I mean feature, which kind of more technically is called the type-inference feature. And what I mean by that is, what happens is that when you're reading through a file of data, somebody, either you or the computer, kind of has to decide what are the types of this data. Am I dealing with strings? Am I dealing with integers? Am I dealing with doubles, floating point, whatever? And one option is for you to kind of laboriously specify for each column what its type is. And the other option is to let the computer kind of figure it out. And so what I'm going to start with is a few small files where I've kind of, each one is kind of a little bit of a puzzle. I kind of make the files look like one kind of thing, and then the last line is a little different. And so it's like, oh no, that's not an integer, that's a string. Or oh no, that's not like a character, that's a floating point number. And I'm going to kind of show you that it's sort of like fun and not especially difficult to do that. So I'm in the Groovy context, which I understand a little better. This also works in the Python context, but I'm a little more comfortable with Groovy, so I'm doing it in the Groovy console. So I'm going to do a couple of imports, and then I'm going to read my demo1.csv file. What I was, I kind of perhaps should have showed the input file, but basically what I had here was like numbers like 1, 2, 3, 4, 5, 6, and then the last line was like the devastating, like tricky line, 7.7, 8 billion, and the string NINE. And so, what you need to do for a file like this is to kind of pick the right type that works for the whole column. And so, since the last line is 7.7, the A column has to be a floating point number. And hopefully that pop up. I don't know if I should make my font bigger, maybe. Hopefully you can see that A has been correctly inferred to be a double, and likewise B, like 2 and 5 are small, so you might think, oh, that'll fit in an int, but 8 billion is too big to fit in an int, so you would hope the system kind of guessed that that would be a long, and it certainly did. You can see from there that that's a long, and likewise for C, NINE is a string, and so even though 3 and 6 looks like integers, they can't be integers because C, you got to find a common type that it kind of works for everything in the column, and so C has to be a string. And so you can see like that with like zero drama, 0 parameters. It loaded the file, it kind of did the right thing. That's kind of a victory for do what I mean. I'm going to do a couple more like that. I've got my demo 2, which is kind of similar in spirit. This one is a little trickier. I got my integers there, 1, 2, 3, 4, 5, and 6, and then the last line I've got A, B, and C, D, and you're like, oh, what's the right column type for this? Well, A is only 1 character wide, and so is B. So those could actually be the character type, and you can see, the system did the right thing for that one and that one. And so the 1 is not an integer; it is the character, like ASCII, 1. And likewise, column 1 is a character type, column 2 is a character type, and column 3 couldn't be a character type because that last row is too wide. It's CD. So column 3 has to be a string type. Very proud of this feature. I don't know. It's like so easy to use that it's like it seems like nothing, but it's kind of works quite well in many cases. I'll do the same thing for demo 3. It's this kind of same story. Here is something where you really have a kind of conflict between two different types. You've got integers and you've got Booleans. Well, there's no single column type that's both integer and Boolean. So what are you going to do? Those are going to have to be strings. And you can see that all three of those are just going to come up as string, string, and string. So that all works great. And so I think the other, along the lines of what I was saying before about kind of browsing, stuff and playing around with files that you might find on the internet, I think that works generally pretty well. And here's the example I had in mind there. This is so here's a file I'm just like literally like sucking from the internet. And it is I think it's a file of Robert De Niro movies. I'm actually not 100% sure. But again, in a one-liner, we can kind of pull it in and sort of take a look and see what we've got. And, and this is an example of what I was talking about, kind of the interactive feel of the whole thing. It's like, well, this looks like it worked pretty well. This looks like I've got maybe a year. I'm actually not sure what that second column is. This is a file that has a score. This is some kind of like Rotten Tomatoes score or something. Sorry. So year, score, and movie name. So far so good, but you're like, oh, what happened there on the headers? And it's like, oh, this was a headerless file, and it looked like it kind of sucked in the first row, and it kind of interpreted it as a header rather than data. But no biggie. That allows me to segue into how you can start setting customization parameters kind of interactively. You're like, this kind of worked, kind of didn't. Let me fix that header problem. And so what you do is you make there's this thing we have called the CSV specs, the CSV specifications, and it allows you to set a bunch of parameters for how you might want to read your file. And I want to, sort of caution, it has a user interface that only like a robot could love, but it is what it is. So like what you do is you at least in Groovy, I don't know if this is any easier in Python, honestly, but at least in Groovy, what you do is you make a builder, and then you kind of you poke in parameters that you want to set on the builder, and then when you're done with the builder, you kind of instantiate it or finalize it, and then your specs object is kind of fully cooked. So in this case,
I will say I think Genfeng's did a good job in this. Is done as named parameters in Python, so you don't have any builders for this. So it does look a little bit prettier in Python, in my opinion.
That's
covers. It's the same thing.
That's great. Okay, that sounds really good. And then thank you, Zhongfeng. I think I'm a little bit part of my own kind of comfort zone is I'm much more comfortable with the Groovy interface than the Python interface, but it sounds like the Python interface is more user friendly. So that's terrific. Anyway, so I make my specs object. That'll just take a moment. And then I'm going to reissue my command, but now I'm going to give it this kind of specs parameter where I've indicated that there's no header row in the input. And, sure enough, in a matter of moments, I said there's no header rows, so the system's not going to generate header rows. And so now it's column 1 through column 3. And then, maybe I'm not happy with that. So maybe I want to, make customize headers. So like my headers equals, this is like literally a Java invocation where I make a list, and I'm going to now use my specs builder, but I'm going to give it another headers, my headers. Whoops, spelled correctly, and hopefully I'm going to read it with the new specs object, reread the same file with the new specs object, and hopefully, I'll now have headers, and it'll look exactly the way I want it to look. And that's great. And then I can now the data looks like it wants. It has probably the types I want, int, string, and now I can, having kind of visualized it and kind of messed with it, I can now move on to whatever I was planning to do with this data in the first place. So, that's like little files and medium files. That file's not that, I don't know how many rows it is. It's not that many. But another kind of interesting data exploration thing is what happens when you have a really big file. There is some kind of like synthetic transaction file. Oh, I don't have in my notes where I got it from, but this file has 264 million rows in it. And so what I like to do is I kind of want to like play with the data, get a little bit of a feel for the data without kind of making the commitment to sit there and load 264 million rows into my system, which might take a little while. So that's another thing you can do with your specs is where's my cut and paste? So like I'm going to make a specs object that has a limit on it that only is going to read the first 100,000 rows of my file, just so I can take a peek at it, kind of get the flavor for the file and not get myself in trouble. And so then I'm going to load my, using that, I'm going to load my transactions.csv, and that should just take an instant. But now I can see the flavor for it. I can see the kind of data that's in there. And I can see if there's anything, get a feel for if there's anything that I need to have kind of special treatment for. One thing I can say off the bat is it's like, oh, it looks like this end date thing is sometimes populated. Sometimes populated and sometimes has the string called null. And I would rather that be a Deephaven null, rather than the string null. And so that would give me another opportunity to say, oh, well, I better set kind of, I better tell my specs to expect a null when they see null. And so I'll do that like null value literal, like that. And by the way, this is like the released version of Deephaven. We now, the new name of that parameter is null value literals, because we can specify more than one in case there's a few different representations in the same file. And then if I were to read the same file, I'm actually, and this is the Deephaven thing, I'm actually not sure why that's coming up as empty. I think there might be a translation somewhere that's turning nulls into the empty string. I'm a little bit iffy on why that's happening, but let's say I've kind of massaged this data and kind of figured it out, figured exactly kind of what I wanted out of it, and then I wanted to see, well, what am I in for loading 26 million lines, 264 million lines of this thing? I might kind of time it a little bit, and I might be like, oh, let's do 10 million rows just to kind of get a flavor for how that's 10 million for how bad it's going to get. And so I'll run that, kind of see how long that's going to take. And it looks like, oh, that was about 10 seconds for 10 million rows. So maybe it's about maybe for this file, it's able to kind of pull in about 1 million rows per second. And so that gives me like a benchmark. I'd be like, oh, well, if I'm going to read 264 million rows, and if I have the memory, by the way, I might want to take a look at how much memory this seems to be consuming and kind of, average it out. But I would expect that loading the whole file will take 6 or 7 minutes. We don't have 6 or 7 minutes here, but at least I can set my expectations by reading, a fragment of it and, a healthy size fragment of it, and just kind of see, to see how it goes. So that's actually kind of the lightning overview of the whole thing. It's a kind of all the sort of demo material I had. We have a bunch of parameters here for controlling the fine grained operations of this thing. You can force a column to be parsed in a certain way. You can also read the file in, like, not only with num rows, but with like starting row and num rows. You can read the file in segments if you've got some kind of more complicated arrangement where you want to somehow read the input file in segments and then maybe merge them together later in some downstream operation. We have custom parsers so that if you have some type, I don't know, like big decimal, say, that you want to kind of natively support, you can kind of plug in your Java code for parsing that type, and that will play pretty nicely with the CSV reader. And there's a million other kind of workaday options like, I've got tabs, not commas. I've got, I need special handling for blank lines or short lines or whatever. There's all kinds of like files that sort of deviate from the CSV specification just a little, and we have a lot of parameters for that. But that's really kind of the lightning overview, and I think I'll stop here and maybe ask for questions or ask for people if they want to try something. I'll kind of hand it off to my audience.
Corey, can you talk a little bit about what you did to achieve high performance?
Yeah. From a programming perspective, it's interesting. I was just like, I sort of took what the kind of existing. Let me step back a little bit. I wanted to avoid what I thought were trouble points for Java, and just to jump ahead to the conclusion, like lots of other people on the internet have noticed these same things and have implemented similar things. So in a way, some of what I did was kind of already observed by other people, and it's possible other libraries kind of do the same thing. But nobody, as far as I know, does the kind of type inference stuff, which I think is very clever. So with all those disclaimers out of the way, here are the things that I thought was important. Number one is to like be really careful about garbage collection. If you do kind of a sort of a naive implementation of a CSV row reader, you might have your row be an array of strings, and what you've already got yourself into is separate Java allocations for each of those strings, and then another Java allocation for the string array. And Java overhead is significant. A 10-character string might have, hard to calculate exactly, but it might have 10 or 20 bytes of overhead on top of it for like the object header, the pointer from the string array to the string. And you can easily, with small strings, see yourself having like 100% overhead or more. And then you're also making a burden on the garbage collector to sort of clean up all of your temporary strings. When you're parsing something and you start with a temporary string and then you turn it to an array of integers, you might feel a little bit bad that you have these temporary strings that existed just long enough to parse them as integers. Maybe you'd like to sort of cut out the middleman and not have those strings in the first place. So it's that kind of thing is very tricky because the Java garbage collector is very good, and so it's a little bit like, well, in which cases does it matter? In which cases don't I care? But in general, a temporary object that you've never created is one that you never have to clean up. So there's that. Secondly, avoiding regexes, and that was particularly acute. We have a datetime parsing library, formerly in Deephaven and also Deephaven Enterprise, which is very general, but it really has the feeling of like, I'm going to compare this date against a dozen regexes and kind of see which one matches. And regexes, even when compiled, are just not going to beat sort of handwritten code. You might see an order, and we did see in our benchmarks, order of 10 improvement, if not more. A compiled regex doesn't mean, I omitted the best possible machine code I could for this thing. It means that I did some pre-processing of the regex. And so getting that kind of out of the picture was extremely helpful. And it's a case where like an ISO date is a pretty regular, it's structured in a pretty kind of structured way. You can read it left to right without a whole lot of, without making your head explode. The ISO dates were actually, in my mind, kind of designed to be pretty good at sort of reading left to right and kind of figuring out what they are. And so that was another kind of big contribution of ours. And
oh, you can continue if you'd like. I was going to throw in also the consumption side is very different than other libraries, and I'd say that's probably the most important thing. It's a columnar consumption model, if you want to talk about that.
Yeah, for sure. So we wanted the output of this thing to be sort of agnostic in terms of data structure. We here at Deephaven like our column sources. Other people might want to just use an array or an array list or something. So we wanted that to be pluggable. We would rather not hand you a data structure of one kind and then have you copy that into the data structure you're actually using. So the interface between your code and this library is via this interface that we call a sink, and it's basically like, here's a chunk of data, write it to your data structure, whatever your data structure is, and that's kind of your job to kind of it's my job to sort of read this file and gather a chunk of data, and it's your job to take that chunk of data and kind of commit it to your data structure. And so the fact that it goes directly into your data structure is great, and it also may mean we don't, not only do we not have an intermediate copy, but there are cases where you might have a sparse data structure. Let's say you've got a CSV file which is like mostly nulls. There are cases, and if you've got a destination data structure which is really good at being sparse, then that's going to pay off pretty big, because we're going to hand you chunks. You're going to scan that chunk and be like, oh, this is mostly nulls. I'm going to pick out the non-null values and populate my data structure. And you can imagine how that's a very efficient kind of interaction. Like, it's not the case in the alternative where we populated some huge thing with a bunch of holes in it, and then you then had to store it in your very nice kind of null array data structure. By giving you the data the chunk at a time, you can handle it in sort of the way you see best. And for example, also you might have some kind of super fancy run length encoded data structure or other kind of compression. So if we hand you chunks at a time, you can kind of compress them, as we hand them to you, maybe, and also kind of reduce memory pressure and processing pressure that way too. Devin, do you think I kind of covered the high points, or did I kind of miss something?
I think so.
And along those lines, I would say as a programmer, and I think we have work to do here as a programmer approaching this library. There's a pretty steep learning curve. Like, getting your first program to work is a little bit annoying because of all of these customizations and of all these these kind of high performance. Being flexible and being kind of high performance comes at a cost of maybe being a little less friendly than some of the other libraries out there. But we benchmarked this, and we are kind of very competitive, and we kind of considered sort of the gold standard to be sort of what Pandas does at the command line, and I think we beat Pandas in either every case or almost every case. There's some kind of funny thing where we're not doing as well with literally strings as I think we should be, and there might be something going on there. But we are quite competitive in terms of like operations per second for all the libraries we've tried, and for Pandas for that matter. And finally, we're doing something that none of these libraries are doing, where you give us a bunch of data and we take a look at it and we think quite hard about what exactly the column type could be. And it's not a heuristic, it's not some kind of random guess. We pick the type that works for your entire column. So if you have, one of my favorite things to do is give the library 99 million integers and then one string, and then it's like, it has to do all this work, and then it's like, oh hell, I found this string, I have to redo all my work. But the library does that and you don't, and that's kind of pretty neat in my opinion. Other questions or thoughts? I can't tell if my internet froze up or if there are no other questions.
All right, thanks, Corey.
Okay, thank you.